Now, what we're talking about today are parent functions and transformations. Parent functions and transformations. Now, these four here are types of parent functions. Now, they're not all the parent functions that we actually have, because here we have constant, linear, absolute value, and quadratic. These are just four, because we also have cubic, which essentially is going to be like the quadratic, but instead of, yeah. You're welcome. So, all right, guys. So quintic is degree 3. The biggest exponent would be a 3. So it follows under quintic. We had quartic would be degree 4, and we can continue on up with any of these higher degree polynomials. We also have something called radical functions. So square roots, cubed roots, they would fall under radicals. And we also have rational functions, so ratio, where the variable is in the bottom of the fraction. We'd also have parent functions for those. But these here are the main 3 or 4 that we're going to look at. Now, the reason we call these the parent functions is because they are the most basic version of each graph. And we also call it the parent functions because every graph of that type will look similar to it. Kind of like with our parents, we look similar to our parents, either one side or the other, whether we like it or not. But it ends up we have the same traits. So linear lines or linear graphs are all going to look like a line. They may be going up faster or slower going down, but they're always going to be the graph of a line. And the biggest degree for the variable is just going to be x, because we could have 2x or 3x plus 4 or any way, but it's still going to be the same shape. It's just going to be a line. Where absolute values have a V shape. So any other type of absolute value function will still have that V shape for the graph. In quadratics, well, what kind of shape does a quadratic have? U. It'll still look like a U. It might be more stretched out or skinnier or anything in between, but it'll still look like a U. It will still have those basic traits for any type of function that we have. Even with our different types of transformations, and that's what we're going to look at today, is some of the different transformations that we can have. So looking at this here, what is the parent function for this graph, for this function here? Yeah, because it has a V shape, so it's going to be the absolute value. So its parent functions, the types that it has, are going to be absolute values. It's going to be the absolute values. It's going to be a V shape. So even if I'm just given the equation 2 times the absolute value of x plus 1, we know that the graph should look like a V. And that's what especially what we're going to be delving into today in 1.3 is really understanding how the graphs work. Because if I know what the graphs, how they should work or what they should look like, I'll have a better understanding of what I'm going to get. Better understanding of the outcomes of what's going to happen and what I'm working with. Now, I will graph the parent function for you. You don't have to worry about that too much. So the parent function looks something like this here, or something close to it. There you go. So looking at this here, what changed between the parent function, the one I just drew, and the one that was given to us originally? It's wider, so the new one got skinnier or narrower. So we can say narrower. And that's some intense rain. So, yes, I would agree it got narrower. But what else happened? Right, down or up, because we're going from the one I drew. So it went up. Because from the parent to the new one, it went up and got narrower, yes? Now, we will get to more technical terms, because we're going to look at these and use this kind of terminology for now, but we're going to actually look at the correct kind of mathematical vernacular that we're going to be using, or the correct terminology. So I'm going to look at this one here. I know I skipped one. That one's a little funky. It's a little weird. Now, what is the parent function for this graph? Quadratic. It's a U. All quadratics will have a U shape. So this falls as a quadratic. Well, thank you. So So the graph I just drew is the parent function of the quadratic function. Now, the one I just drew, so how does it change from that one to the one we were given? It goes to the right. And what else? See, yeah, I didn't pick the pin up, so it's right and wider. Is wider with two D's or one? It's one. I don't know. And that's it. Now, this is kind of helping us kind of identify the different parts, or kind of seeing that there are things that change. Now, all of these transformations are called transformations. A transformation, yep, changes the size, shape, position, or orientation of a graph. Now, the first types that we'll look at are translations. A translation is a transformation that shifts the graph horizontally or vertically, up, down, left, or right. But it does not change its size, shape, or orientation. Yep, we're just moving it up, down, left, and right. Now, before we get too far into this, I'm going to go on and have y'all write these down. And I do have these on the whiteboard also. Yep, just write it right there on your notes. K. Yeah, it's a cursive lowercase k. So plus. Whenever I write T's, I always put a little bit of a tail at the bottom. And that's just from mathematics, because lowercase t and plus without it look the exact same. What these are here are the general, they're only missing one little thing, but that's not a big deal. The general form of these functions, the general form of however they can be used. And whenever we're looking at the transformations, especially multiple transformations, these will help us get an idea of what is happening. because every time a number is in one of these spots, it's affecting a certain part of the function, how it's moving up, down, left, or right. Stretch, shrink, reflections, we'll be able to tell. Now the first one, since we're talking about translations, there's two spots. Let's use a different color. H. Inside is going to affect it by moving it to the left or the right. H moves it to the left or to the right, and it's always moved opposite of what we think. So you can grab a note sheet. So the value inside the parentheses are absolute value. If it's added or subtracted, it's moving it left or right, and it's always opposite of what we think. Now the other spot dealing with these is the K, and it moves the function up or down. Because inside the parentheses really affects the horizontal direction of the function, left to right, reflections left to right. And outside is really normally dealing with up and down, vertical directions. Now we'll be coming back to this in a little bit when we talk about the next types of translations, because we'll add stuff to it. But H and K, H is always with X, K is always with Y. H is going to be left and right, K is going to be up or down for these here. So you don't have to rewrite it, I'm just rewriting it so it's a little bit bigger. All right, guys, so I rewrote that up there just so it's a little bit easier to see on the board because the text is a little small. But let's start off with identifying what's its parent function. What do we think? What would be the parent function? So constant, linear, quadratic, or absolute? It is going to be linear. So absolute should have what? The absolute value bars. Because the key feature for absolute value is the absolute value bars. Because that's what makes it an absolute value function. A quadratic's key feature is a square, because the 2 exponent. And linear is just going to have x to the first power. It is considered linear. So this here is a linear function.
Wouldn't it just be straight across?
So it would be a straight line. So it'd be a line about this here. And the parent function,
So how would you know it? Like the positive 4 on that?
so let's look at that and see. Because there is a reason that the blue one is our new one and the green one is the parent. Green one's the parent. The green one's the one we started out. F of x equals x. The parent function, the linear function, is f of x equals x. So that is the parent function. Now, when we look at this here, the new one we have, g of x has x minus 4. The parent had just x by itself, yes? So the x minus 4, the minus 4, is that inside the parentheses or outside? Outside. We don't have any parentheses, so it can't be inside. So outside the function, in our generic cases, is k. That's the only thing outside being added or subtracted, yes?
Yes, sir.
And k does what? It moves it up or down. Up or down. So it's moving either up or down. 4. Well, since it's negative 4, it's moving down 4. So it tells us that this is actually moving down 4 from its parent function, because the parent function was just x. So when we have x minus 4, it moves the whole function down 4 units. And if we look at this here, well, 0, 0 is where it started. 1, 2, 3, 4. All of these will have a distance of 4 from the original point to the new point. Any questions on this here? And that's it. That's all we have to do. We ready for the next one? So we're not going to graph. I'm not going to make you graph any of these, just even on the homework, because there's too many tools that can actually graph this for you. Desmos graphing calculator, you can actually Google that, will graph for you. All you've got to do is type it in. Now the first thing we want to figure out is the parent function. Well, at least get the parent function, because I rewrite it so it's a little bit easier to see. So what would the parent function for this be? Because our parents are, that we're dealing with, are constant, linear, quadratic, or absolute. Because? So the parent looks like this, your absolute value of x. So this is in absolute value function because of the absolute values. Okay. So our normal function for the absolute value is a times the absolute value of x minus h plus k. Because that's what we have for the general case. Now, looking at this one here, we have the absolute value of x plus 1 on the inside. So since nothing's being added to the outside, we know it's not moving up or down. It's moving left or right. Well, okay, we can say it moves 1 unit. Yes, because it's plus 1. Now, is it going to move to the left or to the right 1? Okay. So, yes, it is left 1. It is left 1 unit. Now, sure. I'll show you this in 2 ways and kind of explain it in 2 ways so y'all can see this. The first is if I went on and graphed this, x, y, -2, -1, 0, 1. So if we plug -2 into this here, well, absolute value, so we have -2 plus 1. Well, -2 plus 1 is -1. The absolute value of -1 is 1. -1 plus 1 is 0. The absolute value of 0 is still 0. If we do it with 0, 0 plus 1 is 1. We get 1, and then this would give us 2. So if I graph this, well, at -2, we're at 1. -1, we're at 0, 1, 2. Well, okay, we can see the entire graph shifted to the left, yes? Okay, that kind of makes sense, but it seems weird how that works. So let me show it in a different way. This here, what's inside the absolute value of ours? X minus h, yes? Well, what do we have here? We have x plus 1, yes? So we have a positive, where in the general case it is a negative, yes? What is the one way that I can change a subtraction to addition? What do we have to subtract? A negative, because a negative and a negative make a So really, what we have here is the absolute value of x minus -1. Because we don't write minus and negative. Thank you. We write plus, because we don't, the redundancies of the negative, we don't do that in mathematics. We just go on and switch it over to plus. That's why it's the opposite of what we think. Because even though the value of h is -1, which means it would move to the left, negative, negative makes it positive. It's still moving to the left, it just looks positive. Which means if it looks negative, it's moving to the right. It's the opposite of what we think. Any questions on up, down, left, or right? Because if it's outside the parentheses or outside the absolute value bars, it's moving up or down. And luckily with up and down, it's what it is. If it's -3 on the outside, it's moving down. If it's +3, it's moving up. Now reflections. A reflection is a transformation that flips a graph over the line called the line of reflection. A reflection line, or reflected point, is the same distance from the line of reflection as the original point. They're going to be the same distance from each other. And this is included especially if you're graphing, because if you know there's a line of reflection, we can actually count from the line of reflection to get the new points. Now, with our graphs, I'm going to go back to this here. Go back to these here. We're going to add something. I'm just erasing this here so I have a little bit more room to write. Luckily with pencil and paper, it's easier to fit stuff than it is on this here. So back to when we wrote these down originally. So on the second page, front of the second page, where you had the general cases written down. So we're going to add something to this here. A, if negative is a reflection across the x-axis. If negative reflection across the x-axis. Let's go and put the rest. Now, I'm going to put one other thing with this. We'll cover it in a little bit, because we noticed on some of the graphs already that we said they got narrower or wider. That is also dealing with this a value across. If A is greater than 1, vertical stretch. If A 0 is less than A is less than 1, vertical I feel like there's an A in stretch. Huh? Okay. Yes. STR. STRETCH. Yep.
Why is everything wrong?
You're good. So the vertical stretch and vertical shrink, we're going to come back to those. I decided to go on and have y'all put those down because that way you don't have to flip back and forth because it's still attaching to the same thing. Now, the main thing with reflection is if that A value is negative, it's going to reflect it across the x-axis. Now, if we've noticed so far, H inside really moved it left or right. We dealt in this horizontal kind of movement. And what it's really boiling down to is everything inside, parentheses, inside those absolute values, is dealing with what we call the input, what we're putting into the function. When the numbers we plug in, the domain, what's inside the absolute value bars or inside the parentheses deals with the input, the numbers we plug in, the x-axis. Outside those parentheses is dealing with the output values, the y-axis, up and down. So if we notice this here, A is outside, reflection across the x, that seems a little counterintuitive. But if we flip it across the x, it means it's going from going up to going down. Our y values are changing from positive to negative. Or inside, we can have a reflection across the y-axis, which switches our input values from positive to negative or negative to positive. And that value would be right in front of the x. If the x, the sign in front of the x inside parentheses or absolute value bars, was negative, then it would be across the y-axis. Now, let's move. When we look at this here, the graph of negative x squared it is quadratic. That would be the parent. So the parent function would be a quadratic. F of x would equal just x squared. So this should be the first one of example 3. Nice little graph that they have there. No, I was actually pointing at the book.
Oh.
Yeah. It is the quadratic function. It is, parent function is f of x equals x squared. Now, we do see that the new one does have a negative sign out front, which means this would be a, what? Reflection across the x-axis. It would not be a reflection across the y-axis. The y version of this would be this here. The negative is inside the parentheses. And for this quadratic, it really wouldn't do anything because it actually just puts all the sides that would be negative onto the positive and all the positive straight back on the negative. We would need something to move it a little bit more. So this here is a reflection across the x-axis. Let's see if I can get a different color. More.
Yeah, right.
Yeah. All right, guys. So this here, if we wanted to look at the numbers for it, so let's just say 2. If we plug 2 into x squared, well, what is 2 squared? Because 2 squared would be 4. If we plugged it into p of x, well, 2 squared would still be 4, but what happens now? It is now negative. So the original function was 2. For our new one is 2, negative 4. So it took the point that was originally at 2, 4 in the positive first quadrant, positive x, positive y, now has a positive x but negative y. It flipped it across the x-axis. So really, if we looked at the overall function, this here is the parent function. Yep, it should be here, here. And here is the p of x. It reflects it across the x-axis.
Class and club sponsors. I've just been told that we need the fundraiser ideas by 3 o'clock this afternoon so that they can be posted on the board agenda. I still have not received fundraiser ideas from FCLA.
All right, guys. So any questions on how this worked for this here? We like this so far? Not too bad? So, yep. All right, guys. This here would be linear because it is x. It doesn't have a power, doesn't have absolutes. So this here would be a linear function. And the parent is f of x is equal to x. That's just the linear function. Its parent. Now, what do you notice that is different between this and the one we have? The negative, yes, because it's negative x. The one, the parent is just x. Caleb, guys, focus up here. Because the one they gave us is negative x. Our parent is just x. So that negative did change. So what would that be? What transformation would that be? Okay. Across? Mm-hmm. 130. Okay. Any questions on this here? So, what is the parent of this graph, or this equation here? X, so that would be considered a linear function. So its parent is linear. Now, what is the transformation from the parent function to this here? So it's our 3, isn't it? Is it inside parentheses? So it's not left or right, so that means it has to be what? Up or down, and it would be? Because up and down is exactly as we see it. Left and right, inside parentheses is the only one that's the opposite. Inside parentheses is the opposite of what we think with addition and subtraction. So this here is just going to be up 3. We'll finish this tomorrow and start the next one.